G'day, today I want to talk to you a little bit about the locus of a point. But this time it's going to be in the shape of a parabola rather than the circle that we looked at before. To do this, I'm going to look at the example 8 first, and then I'll come back and talk about this focus and directrix as well. But let's go to the example. So here it says verify that the set of all points, P, X, Y, that are equidistant, there's that word again, from the point f of 0, 1 and the line y equals -1 is a parabola. So let me just explain what we're trying to do. We've got this particular point here, which is 0, 1, and we've got this line here, which is y equals -1. And what we're saying is that all of the points that are equidistant between these two lines are actually in the shape of a parabola. So, for example, the equidistant between this point and this line here is that point there. Then if we move along a little bit, let's just say from this point here when x is 1, the shortest distance from this line up to somewhere here will be at right angle. So we're sort of going to go do something like this, and this one is going to do something like that, and we're going to keep doing something like that, and we're going to end up with something in the shape of a parabola like that. Okay, and that on either side as well. So this distance here is going to be the same as this distance here. This distance here is the same as this distance here, and we're going to keep playing around with that a little bit. So hopefully you get the idea of what we're doing here. I'll rub all that out. Okay, so the way we're going to do this is, because of this equidistant thing, we're actually going to use the distance formula again, just like we were using for the circles. So I'm going to say that the distance from this particular point here, 0, 1, and somewhere along this line here, I'm going to choose a random point over here called x and y. Okay, I don't know what these values are, but I'm going to get this distance from there to there and this distance from there to there. Now, this distance here, this point here will be some x value, and in fact it will be this same x value because of the perpendicular line that the right angle that makes it the shortest distance, and this being -1. Okay, hopefully that makes a little bit of sense that these two x values are the same, given that that's the shortest distance from that line to that particular point there. So I'm going to get this formula, and it's going to be the square root of, I'll do between this point and this point here, so that's 0, 1. So I've got x minus 0 squared, because that point there is 0, and I've also got y minus 1 squared. And I'm going to make that equal to the other side, which is x minus x squared, which is actually just going to be 0, but we'll go with that, plus y minus -1 squared. Now I think after here, everything should be fairly self-explanatory. I'll just make that a 0 over there. I'll just do a little bit of creative work. There we go. Everything from here, I think, is going to be fairly self-explanatory. I guess it's, getting to this point is probably a little bit tricky, but I'll show you in the next example as well how I do this. So hopefully you can go back and have a look, and if you need to. So now I'll just do the rest of it. I'll square both sides, and I'll do a little bit of playing around. So that's x squared plus y squared minus 2y plus 1 equals 0 squared, so it's 0. Y squared plus 2y plus 1, because that ends up being a plus 1 there. Okay, and now I can just rearrange and find out what y equals. Y squared and y squared on the same side, on each side, that means we can cancel them out. Plus 1 and plus 1, we can cancel those out as well. And all I've got left is x squared minus 2y equals 2y. Add 2y to both sides, I get 4y equals x squared, and that means that I've got y equals 1/4 x squared. And that, friends, is a parabola. Let me show you, if I actually sketch that, we'll see what it looks like. Oh, there we go, magic. So we've got this line here and this line here, and what we're saying is that distance there is the same as that distance there, that distance there is the same as that distance there, so on and so forth. So hopefully you can see how that kind of works. Okay, So now let me just talk a little bit about this focus and this directrix here. So this particular point here, this 0, 1, which we were given, this point is called the focus. Okay, and this has lots of applications. You can have a look in your textbook to see some of these things, but I guess light reflecting off torches and that sort of stuff, it's pretty interesting, doing all this sort of stuff. But this is what we call the focus here for specialist maths. This is all we need to know, that's the focus. And this here, directrix, this is the line here. So the line y equals -1 is the directrix. Okay, so hopefully that's helped a little bit. The next video I'll look at example 9. Thanks.